Okay, chapter 8.4, solving two-step inequalities, and this is just like solving two-step equations, other than it's inequalities. We're going to keep multiplying and division positive, so that we don't have to worry about anything strange, and we're just going to graph our solutions. It's the same way you solve two-step equations, so this should go quickly. I think you guys will be happy with how this works. So, example 1, solve 3x plus 2 is greater than 17. So we're just undoing everything until we get x all by itself. We're going to just undo everything one step at a time. It's just kind of how that works. So this is 3 times x plus 2. And we're working our way towards this x, but we're going to start by subtracting 2 from both sides. We can't divide by 3 yet because we would also have to divide 2 by 3, and we'd have to divide 17 by 3, and that's possible, but it would give us some weird fractions and stuff like this. So we're going to start by just getting rid of the 2. Positive 2 minus 2, 17 minus 2. So that 3x is greater than, because this equals 0, 17 minus 2 is 15. And now we have numbers that look a little better. Okay, I wanted orange. There we go. 3x is greater than 15. So 3 times x, and we can already kind of guess that x is probably 5. Okay, so but whatever x is has to be greater than 5, but we'll figure that out. So we're going to divide both sides by 3. And this simplifies down to just 1x, just x. X is greater than 15 thirds, which is 5. So x has to be greater than 5. And if we go ahead and graph this now, okay, x has to be greater than 5. So we've got 2, 3, 4, 5, 6, 7, 8. You have to imagine these are all evenly spaced and that we go to infinity in both directions. We can never do it exactly right, but that's kind of our plan. Okay. And since x is greater than 5, we go to 5. It's not greater than and equal to, it's just greater than. So we're going to draw a circle that is hollow right on 5. And greater than points to the right. Okay. It's eating everything to the left if you're thinking about the Pac-Man mouth. That didn't work. There's the Pac-Man mouth. It's eating the bigger ones. Okay, but it points to the right, and so we just kind of keep that going with that idea. And there's our arrow. It looks kind of like the greater than sign, pointing off to the right. Everything greater than 5 works, not 5 itself. Okay. There you go, example 2. This is more example 1, but just part B. I guess that makes sense. We should see one more question. So y over 6, which is y divided by 6, minus 9, is less than or equal to 1. That's what that looks like. Okay. What happens next is we have to try to get this 9 out of here. So we're going to add, which is the opposite of subtract 9, add 9 to both sides. Negative 9 plus 9 is 0, so that just leaves us y sixths is less than or equal to 10, because 1 plus 9 is 10. Then we have to multiply both sides by 6. So that's y over 6 times 6. You could write 6 ones just to help you make sure you see it. It's 10 times 6. So we multiply both sides times 6, and those 6's cancel. And so then our answer starts looking like y. It says 1y is less than or equal to 60. And that one, when we start graphing bigger numbers like that, we can use, obviously you could guess maybe, we're going to count by tens, maybe say 30, 40, 50, 60, 70, and 80, and this is that y is less than 60, so when we come over here to do 60, we're going to make a hollow circle, but it's also equal to, which means that we need to fill in our hollow circle to make it a big round solid circle. And it's less than, which is in the left direction. And put little arrows on our arrow. There we go. Y is less than 60. Looks like that. And that's how that works. Now, there is a real-life application for example number 2. And then I noticed that there are some area problems coming up, but you guys can work those out or I'll help you in class. Okay, so real-life application. Members of a club are selling pizza for $8 each. So pizza is $8 each. So that's $8 per pizza. Write an inequality to represent the number of additional pizzas the club must sell to reach or exceed the goal. Oh, they're using a picture. They have sold enough to make $1,200, but their goal, let's start with an O, or their goal is $3,600. Okay, so they have already sold $12,000 or $1,200 and dollars worth of pizza, and they want to sell $3,600 worth of gold, or $3,600. That's their goal. So we have to write an inequality to represent the number of additional pizzas the club must sell to reach the goal. So we have the goal on one side, and they want to sell more than or equal to their goal, and so that's their pizza, P-I-Z-Z-A, on the other side. Now pizza really can be split into what they've already sold and what they still need to sell. Alright, so we're going to try to write this down. So this pizza that they've already sold plus the pizza that they still need to sell has to equal more than their goal. So we can start writing this down as an equation now. So we've got the more than or equal to, or greater than or equal to sign. The goal is 3,600, so we'll just put that number in. And over here they've already sold $1,200, but they still need to sell more. And this one, they still need to sell. Before I write that in, we need to remember that that's $8 each. So that would be like $8 times the number of pizzas. So we'll use P. They use P in the book, so I guess that makes sense. So we'll say 8P. So it's $8 per pizza. One pizza would be $1, or $8. Two pizzas would be $16, and so on. And so this will just add on to the $1,200 they've already spent. This is an equation. This is how they did it in the book. And that's how I wanted to do it. So I'm glad that we agree, the book and I, on what it should look like. Now what happens here is then we want to get rid of this 1,200. So we're going to subtract the 1,200 from here, and we're going to subtract it from here. And we'll see that we're left with 8P is greater than or equal to $2,400, $2,400. And see, we reduced 1,200 that we already had. We took it away from our total goal, so now all our remaining goal is 2,400. The nice thing about this is the 24 is divisible by 8, so I don't even need a calculator. I'm going to change colors though. Divide by 8 over here and divide by 8 over here, and we kind of have to come over here a little bit. So P remains. P has to be greater than or equal to 24 over 8 is the same as 3 over 1, because 8 times 3 is 24, and we leave those two zeros, that is 300. And if you go ahead and do that on a calculator, you'll see that 2,400 or 2,400 divided by 8 is 300. So they still need to sell 300. What does the 300 stand for? If you think about it, it stands for the pizzas at $8 each. So they still need to sell 300 more pizzas. That would be what they need to do. Sell 300 more pizzas. Makes me hungry. That's the answer to what that will solve all their problems. Now hopefully they can sell 500 pizzas and make even more than what they're trying to make. But that's their goal. If they want to meet their goal of $3,600, they have to sell 300 more pizzas. All right? keep working on that. You can watch that example again if you need to, but it makes sense. You have to make sure that you understand what we're doing to change the word problem into an actual math problem.